Hello and welcome to another sunny day in Thailand as we are all at our you-know-what place during the middle of all of the you-know-what stuff. But I want to bring you a little mini project that is interrupting another project that I'm working on, which is interrupting another project I'm working on, which is I bought this condo. I already had this condo. I knocked down this wall, and now I have a big open space. And I'm finishing off things like the border between the two rooms, finishing up the trim pieces, moving a lot of stuff from over there to over there. And one of the things I did was expand my smart home concept to these overhead lights. Now each room has 4 plus 1 in the entryway. 4 plus 1 in the entryway. So I thought, I'll buy some LED smart bulbs from one of the normal places. And this is what I found. On the website, it says this is a smart LED bulb. It does all the right things. It's got RGB colors and a white channel, so you can make it just white, a pure, nice white. They're Wi-Fi based, and there's an app to control them called the Magic Home Pro app. And apparently this has a controller in it that's used by a few other of these smart bulb concept things. So I thought I'll use the app. I'll bring it into my home assistants, which I've already got both of the aircon systems, the Samsung TV, both of my solar power systems. There's one there and there's one there, which I have not finished documenting that for you guys. I've got this lamp is on here, and I tried to set up for these other lights. Well, you know how it goes. Home Assistant is supposed to have it built in for the thing that drives these bulbs, but it works unreliably. Some of the lights turn on and off, some of them don't. None of them will change colors, and it's just garbage. So I thought, let's look at this thing and figure out if we can put Tasmota on it like I did for all the other control things I've got going on in my condos. So I went on to Lazada, which is a local Thailand electronics and everything you want to buy kind of place, and I found these bulbs. They were about $6.50 equivalent. So I bought 12. And they're totally generic. There's no branding on them whatsoever. It just says RGB CW, 7 watts Wi-Fi. The setup worked well with the Magic Home, what's it called? The Magic Home Pro app. The setup went well. I got them all locked in on an IP address, which I bonded in my router, so they will never change their IP. Then I went into Home Assistant and set it up, and it's just completely unreliable. So let's take a look inside this thing and see what it looks like. Now, in Home Assistant's defense, there are 2 things on the market called Magic Home blah 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 product name. Home Assistant supports one of them. And I have the other one. So, hence, we're going down a different pathway to solve this problem. I feel a bit like Big Clive here, but I'm not going to draw out the circuit for you. This plastic lid pops off fairly easily if you pry something underneath. Then we see an interesting bit of engineering. This board is all LEDs, and you can see the red, green, blue LEDs around, and then a distinctly different set of white LEDs, which gives us the ability to make pure white, which is nice. And then there's this, let me get a pointy thing, this funky little connector. I was hoping that this had the transmit, receive, power, and ground so that I could flash Tasmota onto it, but no, it is simply a daughter connector that goes down to this board, which, if we have some light, this board has the actual controller on it, and all the AC end is down inside there. Sorry about the light. And the control board has an ESP8285 chip on it, which, from my reading of Tasmota, is supported. Now, this board doesn't come out. Somehow, magically, it is soldered way down in the bottom to the tip and the ring of the AC bulb. So that's the bad news. The good news is there actually are transmit receive 3.3 volt and ground pins right there, which you can't see, but trust me, there are tiny, tiny pins right here for the UART. These are the ones we're looking for to flash Tasmota on this. I'll have to use a fairly recent version of Tasmota from what I understand. Okay, and here's where we get to the microsurgery part of the deal, because inside here, you don't have a nice set of header pins. You don't have anything nice. You have very, very small solder pads, almost like test points on other circuit boards. And you need to hook up 3.3 volts ground, transmit and receive back to the FTDI board. But you also, because there's no push button, like on the Sonoff devices, you hold a push button down on power on to get it to power up. You have to go all the way down inside here. Next to the R32 marking 100, there is a solder pad. That is GPI 0. You must ground that for it to be able to go into programming mode with your USB adapter. So we need another little micro cable that comes to the ground wire back here. Now, with all the microsurgery done, let's pop over and see how we can get this thing programmed. Okay, we're wired up. I plugged the board into a USB port, and I believe we're running on COM7. Let's check that. Yes, that's our FTDI, so we're good. Now we're going to run our standard command to read whatever is currently in the flash, and we're going to save it away in case I ever need to restore it back to its magic state. And contact. Okay, we're reading. I'll zoom through this and get back to you when we're done. And we're done. And after unplugging and plugging the FTDI board back in, we're going to erase the firmware that's already there with the standard command. And we're done. So I downloaded the latest version of the Tasmota binary, which as of April 4th, 2020 is version 8.2.0, codenamed Elliot. I've downloaded it here. I've got my command set up to flash it to the board. One thing to remember is if you have any spaces in your path, you need the quotation marks, so the Windows figures out where to send that. So 3, 2, 1, contact. There we go. And we're done. Okay, would you believe I do not have a light fixture that takes a bulb that size except for the ceiling? So I've put the bulb in here, I've left the cap off, and I'm going to do the standard Tasmota power up sequence and get it onto the Wi-Fi network. Cross your fingers, then we can work on configuring it from the other computer. Well, it's flashing. That's a good sign. Okay, I found it. I configured the initial Tasmota screen to point to my Wi-Fi network and password, and it stopped flashing, so let's go check it out. So I found a setting in here called Magic Home, but as I was trying to use the default Magic Home and Home Assistant, it's not quite right. Now it does turn on and off, so we go off and on, but it's supposed to be quite bright right now. It looks a lot of blue, but it should be red. That's medium red. This should be yellow. That should be green. That should be blue. And that should be red. A lot of red. So I'm going to try the alternative, or alternative, depending on how you speak English, firmware that specifically says it supports this bulb. Okay, here we go into yet another alternative open source firmware for smart home devices. When I did a search on the product number that I found inside the bulb, ZJ, LB, RGB, WWL, I came across one of the only posts on the entire internet which has the exact part number, and this is our bulb. Do you recognize this? Yes, you do. And this is support that's been added to a thing called ESPurna, don't know how to say that, by Will Wilsman back in my good old town of Austin, Texas. So he added support for our bulb into ESPurna on January 13th of this year. And you can see how we wired up ground, power, receive and transmit, and then there's another one soldered onto that 100 pin. And so I asked him, I've got the same bulb, but I can't contact it. Oh, I see the blue wires connected. Where does that go to? And 3 hours later, he replied back and said the blue wire is GPI 0, which needs to be grounded. And that is, folks, how we got the original Tasmota firmware installed on here. But now I'm going to give his code a try. So if we jump over to ESPurna, it's here on GitHub, as everything else on the planet is. It's custom firmware for our kind of smart switches, lights, and sensors. And if we pop over to the supported hardware page, you can see all of these modules defined by a build flag and a board type. If we scroll down to our part number, there we are, Magic Home ZJ LB RGB WW_L Magic Home light bulbs. So it's in the code, but it has to be built with this particular flag turned on. So let's see if there's a pre-built binary that I can use for this. And if we jump over to one of the nightly builds, because the latest release build is from December, so that's not new enough to catch Mr. Wilson's update. But if we look at the nightly build and we scroll down, you can see here is the compiled binary with our part number in it. So I'm going to download that, and then we'll go ahead and follow the exact same procedure to flash this onto the bulb. Okay, I've got the nightly build downloaded, and we're going to see if we can make this flash. Plug in and contact. There we go. And we're done. Okay, now that you've got ESPurna firmware into the bulb, you screw it into a light socket and turn it on. And the configuration starts off similar to Tasmota, but it gets weirder after that. So, first thing you do is with your phone, you look for an access point named ESPurna-something. You connect to that. You then browse to the IP address that the bulb has given itself on this Wi-Fi network. Now, they've added a ton of security because when you first go to this website, you have to log into the bulb. You enter admin as the user ID and Fibonacci as the password. Once you do that, you will be asked to change the default password to something of your own imagination. And you're trying to do this all on your phone, so it's not the most convenient thing. Then, after you've generated your own password, you have to log into the bulb again with admin and then your own password. Now, once you've gone through that, you will be presented with the internal web page of the bulb that lets you do things like turn it on and off and set the colors. But on this side, there is a giant menu of things you can do. Now, on the phone, this is closed to the side, so you need to click on it to make it pop out. What you want to do is go to Wi-Fi, and this is where you have to go to set up the bulb to join your Wi-Fi network so you can get useful things done. Now, this is tricky. You can do this scan now thing, and it'll give you a list of all the Wi-Fi access points you find, but it won't let you select one to log into. On your phone again, you have to enter the exact SSID of your Wi-Fi network, and then you have to enter its password. But do not click Add Network. It's going to prompt you to add another SSID that it uses as a backup in case it can't connect with the first one. When you enter your SSID and password, click Save. The bulb will reboot, and then it will join your Wi-Fi network, and then you're able to access this page from any web browser that's also connected to your Wi-Fi network, and you can go in and change the settings to allow it to interconnect with Home Assistant. Okay, we're cooking with LEDs. I'll run you through. So I can go off, and I can go on. I can adjust the brightness, and I can circle through all the colors. We start in red, we're kind of orangey. Did you know that orange doesn't exist? Or is it brown? Brown doesn't exist, it's just dark orange. We move to yellow, we come into a nice green, we move to kind of an aqua, we go into blue, we go to purple, and back around to red. We also have two white channels. This one is a bright white, and this one is more of a warm white. So we're fully under control through the ESPurna firmware. Now, as you can see, it does have support for Home Assistant and MQTT. I gotta go figure out what Home Assistant is expecting this device to respond to in terms of commands and responses. That's the next step. Okay, we have a working bulb. Now let's get it integrated with Home Assistant. And we do that with two settings. First thing we do, come in here, we'll work our way down the tabs. You can set host name, description if you want. I turned off Alexa integration because I don't use it. There's no need to have any memory or CPU cycles for that. For Home Assistant integration, click Discover, yes. That's very important, otherwise Home Assistant will not see the bulb. And you can leave this prefix. This has to do with the auto discovery. I left it alone and it worked fine. In terms of lights, you need to tell the light bulb how to behave in terms of the commands and responses that go back and forth. So I turned everything on. All of these get turned on, except gamma correction and CSS style. CSS style explicitly is incompatible with Home Assistant MQTT. So just make sure you've got these first four set to yes. And then the big one is MQTT. You need to enable MQTT. You set the IP address or the full DNS name of your MQTT broker server, what port it's running on, which I've got the standard port, my user ID, and my passport. You can leave the client ID blank. I left that alone at 0. I turn retain on. I think I left keep alive alone, and the root topic. This is very, very important. This is how Home Assistant will talk to your bulb via MQTT. So you want to make it unique, and you want to make it descriptive to you so you know what bulb you're talking with. So this is my number 2 light bulb in the ceiling of room number 115. And nothing else is that important. I set the time zone here, no schedule. I didn't do anything with the switches, no ThingSpeak, I didn't change Wi-Fi, so I just did save from here. Before we jump over to Home Assistant, I wanted to lift up the curtain a little bit on the underlying MQTT capabilities of the bulb and the firmware. And if you go to this documentation page, you can see that everything acts with that root topic that we just said, and then followed by some keywords. And there's a whole bunch of them. So if we want to say turn the relay, and the relay actually turns the bulb on and off, we would say ceiling light 115-2/relay/0. And that's the 0th relay. The payload is a 1, that turns that relay on. A 0 turns it off. 2 toggles the bulb. Then if you want to set your RGB values, you can do it in the HTML way with a hex format. You can set your brightness. You can do all of this other stuff. Now if I jump over to Node Red, I created some test flows that send the on, off, and toggle commands to the light. And the off payload is 0, the on payload is 1, and the toggle payload is 2. And we send it to here, where we use our root topic relay 0 set. That's all we do. And if I come over here and I can click on, and I can click off, and I can click toggle, 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 and I've also got colors that I can send. If I want to send red, I send FF0000, green and blue similar, and the format is the same topic ID RGB set. So if I come over here, I'm going to change to red, I change to green, and I change to blue. So you can do this all by hand, but Home Assistant's got all this stuff built in and does quite a nice job. Now to tell Home Assistant that you've got some ESPurna devices, all you need to do is first, obviously you tell it you're running an MQTT broker, but you've definitely already got this in place already for your other devices. Then you just add this line, discovery true, discovery prefix Home Assistant. Couldn't get much simpler, and if I pop over to my configuration.yaml, you see that I've got that right here. And then as soon as the bulbs boot up, they will make Home Assistant aware of their existence. Now I always do a full restart of Home Assistant anytime I muck around with the config files. So you'll come back into the main page, go down to configuration, and then devices, and then you'll see it. There will automatically be a line for it here, given the topic name, the manufacturer's Magic Home. This is all being pulled by the support. That's our board. You single click the line, and here's all the information. You can actually turn it on and off from here, and you can change the colors, the brightness, and everything else right from here. But what we want to do first is go up here to the setting, and you can give it a nice name, and you can set which area it's in, which helps you with your scenes and scripts later on. You can add it to the main user interface Lovelace here, or you can do it by hand over back on the main page. So you can go in and configure. You can say, I've already done it here, but I'll do it again. I'll add it and duplicate it. I'll edit my living room card. I'll come down here and I'll go through the entities list, and there it is. And then I'll save. Now we've got that bulb shown twice. We exit out of edit mode, and now we've got 2 entries for this bulb. Okay, we're at the end of our journey. We now have control over this light bulb via Home Assistant through MQTT through the ESPurna firmware. So I can come along here and I can click on either one of these. They're going to be They're duplicates, so they're going to show the same thing. I can turn the bulb on and off and on, and you'll see that the icon actually reflects the color that the bulb is set to, which is a pretty cool feature. If I click the name, I can pretty much do anything I want to this bulb. I can change the color to purple or to green. I can bring in the white values, the warm white, the hard white, and I can turn it on and off from here, just like any other device on the network, and it works pretty well. So thank you for sticking with me for so long. This is basically meant to document it for people coming in the future. And my thanks to Mr. Will Wilsman from Austin, Texas, that got me started. And I'll add a link down at the bottom of this in the forum to tell them that this video is available, and anybody else who's searching for it can find it. And that about wraps it up for today. Stay safe, stay healthy. As you stare out on my beach, I would ask you to subscribe to my channel and click like on this video so YouTube thinks I'm worthy again, and I have so many people on my channel that they'll give me 10 cents a day in ad revenue. So I thank you for that.